Hello, this is Scott Strategies in Math. Today in geometry, we're going to be classifying polygons. So, a polygon is a closed figure formed by three or more line segments that connect at vertices, and each side can only intersect two other sides once at each endpoints. There's no curved parts. So no curves. So here's A, B, C, D, E, and we would call this polygon, A, B, C, D, E. We name polygons by their vertices clockwise. So if we start at A, we would say A, B, C, D, E. If we start at D, it would be D, E, A, B, C. But it's just easier to go A, B, C, D, E. Vertices is just the plural form of vertex. So A is a vertex, B is a vertex, C, D, E, they're all vertices. Convex means no sides are caved in. So convex. Convex and concave. So when you extend any of the sides, so let me give you an example of a concave, and that'll give you an idea what convex is. So let's have, I don't know, that, and then we have that going on. Okay? If you extend any side, so if I extend this side, that vertical line, or if I extend that, or if I extend that, so now notice how those lines, they're not going inside the object. But if I extend this mountaintop here, it goes inside. So that would be considered a concave object. So let me redraw the object. So this would be considered concave. Convex means if you extend on the sides and they don't go inside, then it's convex. So if I have a triangle, I extend that side, 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 extend that side. None of those lines go inside the object. Okay? Equilateral means all the sides are congruent. They have the same length. So when we think of same length, most of the time we think of a square. But you can have equilateral triangles, equilateral other polygons. Equiangular means all the angles are the same. And in a rectangle or a square, they form right angles. So that's an example. Wish I could draw that a little bit bigger. Let's try that. Let's say we have a square or a rectangle. This angle here is the same as this angle here, which is the same as that angle here, and that's the same angle. Equiangular. And then we have a regular polygon. So a regular polygon means it's both equiangular and equilateral. So all the sides are congruent and all the angles are congruent. Alright, now I'm missing something here, but we'll go back to that in a second. So here we go. Oh, right. Example 1. Sorry. Got distracted. Example 1. Tell whether the figure is a polygon. If it's a polygon, tell if it's convex or concave. So it is not a polygon because of this line going straight through the middle. We're not allowed to have more than 2 sides intersecting at one vertex. Okay? So this one is a polygon. As you can see, it's just my rotated object at the beginning, A, B, C, D, E. And is this convex or concave? It's convex, because if I extend any of these lines, it does not go inside the object. This one is concave, because if you can see here, that little arrow, that goes inside as soon as I extend that line, or this line. And then just in case, let's do one more. Once again, that is not a polygon. So this one we only have two sides intersecting at each of the points. But it's not closed. So it's like there's this open pocket here, open pocket here. Oh wait, sorry. And then this middle one, that's being intersected by four sides. So that's not a polygon. Hourglass is not a polygon. And remember, polygon also cannot be curvy, no curves. A regular hexagon has the side lengths shown. What is the length of each side? So regular means all the sides are the same length, all the angles are the same. So we're just going to use the fact that all the sides are the same. So this is equal to that. So 4x plus 3 is equal to 5x minus 1. We'll subtract 4x from both sides and get x equals, add 1 to both sides, and get x equals 4. Now we know what 4 is, or x is, plug it back into the equation. 4 times 4 plus 3 is 19. And if I did it right, 5 times 4 minus 1 does indeed equal 19. Alright, classify the polygons shown by the number of sides and tell whether the polygon is equilateral, equiangular, or regular. So, I'll tell you right now, this is a regular, because, so you know it's regular because it tells you by the tick marks that all the sides are the same, and then the one loop for all the angles means all those angles are the same, so it's regular. Now, how do we determine the name? So this is called an octagon because it has 8 sides. All right? Now, oh, that's not what I wanted to do. Let's insert a page here. Insert page. All right, let's go over the other polygons. So a polygon cannot be one-sided. So no one-sided polygon. No two-sided polygon. It's going to be open, right? No matter how you do it, there's going to be an open spot. But there is a 3-sided polygon. So I'm going to split this up. We have sides, Actually, let's do a number of sides on this side, and then the name. So 3-sided, you should know that's a triangle. 4-sided, we call that a quadrilateral. Quadrilateral. So those are your rectangles, your rhombuses, your diamonds, your squares, all that. Quadrilateral. Quadrilateral. 5-sided is pentagon. We have the Pentagon in DC. It's in the shape of a pentagon. Right? Well, I mean, it's probably not perfect pentagon. I mean, it is. It's in the shape of a pentagon. Okay, anyways. 6 is a hexagon. 7. So this one, you can say septa, and I'll allow it. Septagon. Or heptagon. 8, octagon. 9, nonagon. 10, decagon. I think, what is it? 12 is dodeca? Is that right? Let me check. Dodecagon. Yep. Dodecagon. Need to grab some water. All right. So you need to memorize what all these means. So 3-sided triangle, 4-sided quadrilateral, 5 penta, 6 hexa, 7 is septa or hepta, 8 is octa, 9 is nona, 10 is deca, 12 is dodeca. You do need to memorize those because some of your questions will ask you or tell you that it's a nonagon. It's like, what's a nonagon? It's 9-sided. And that's it for section 1.6. Let me fix my cough. Have a good day.